Right, question 6. Figure 1 shows the sector OAB. OAB. I have a circle with centre O, radius 9. So straight away, I don't know if we'll need this, but we know that this length here is going to be 9 as well, because it's the radius of this circle here. And the angle is 0.7 radians. So make sure your calculator's in radians. With most of the calculators, you just press shift and then the mode setup button, and it gives you a menu, and you press number 4 to get it in radians. Make sure you know how to do that, especially because the question earlier was in degrees. We have to find the length of the arc AB, which is this bit here, and find the area of the sector OAB for the first bit. You need to learn the formulas in radians. They're actually more simpler in radians than they are in degrees. For the length, it's just r theta. So arc length is just r theta. And for the sector area, it's a half r squared theta. It comes from just using the GCSE formula of pi r squared times theta over 360, and then replacing the theta with the 360 degrees, sorry, with 2 pi, because 360 degrees is 2 pi radians. But really just remember those, it's not a lot. So the length is r times theta, which is the radius is 9, and theta is 0.7, which gives 6.3 centimeters. So that's the arc length, 6.3. And for part B, half r squared theta equals 0.5 times 9 squared times theta is 0.7. And type that into your calculator. I'll just do it quickly there. Get off. 0.5 times 81, because that's 9 squared, times 0.7 gives us 567 over 20, which is 28.35. So 28.35 centimetre squared, because it's area. The next bit, we may have to go on to a new page, I think. The line AC, shown in figure 1, is perpendicular to OA, and OBC is a straight line. Find the length of AC, given your answer to 2 decimal places. So I've just moved on to a nice new page here. We have to find the length of AC, which is this bit here. Now what we've got is we've got a right angle triangle. Oops. We know this is 9. We want to find this, and we know an angle. So we can just use SOHCAHTOA. We've got the adjacent. This is going to be the hypotenuse opposite the right angle. This is going to be the opposite the angle that we know. This is the adjacent. So we've got the adjacent, and we've got this side here that we're trying to find. So it's A and the O, so it's tan. So for tan, it's TOA, O and the A. So we know that the tan of 0.7 is equal to the opposite, which is x, divided by the adjacent, which is 9. So if we're finding x, we want to multiply them together. So x equals tan of 0.7, make sure it's in radians, multiplied by 9. I think you may have to close off the bracket for most calculators as well. Don't put the 9 inside that bracket, that would be something drastic. So if we just type that in and do the tan of 0.7 equals that, multiplied by 9, we get 7.58. So 7.58 to 2 decimal places, centimeters. So that's this one here that we now know, 7.58. Next part, for 3 marks, the region H is bounded by the arc AB and the lines AC and CB. Find the area, given your answer to 2 decimal places. So all we need to do is get the area of the big triangle and subtract the area of this thing here, which we already found earlier. It was the area of the sector was 28.35. So we need for part D We need area of triangle OAC, and we need to subtract sector area. And we know what that is. I've forgotten it already. Was it 28.35? Yes. But we need to find the area of this here. I know don't try and go with, well, I suppose you could really, half base times height, because we do actually know the base and the height with it being a right angle triangle. I was going to say go with a half AB sine C. That's usually what you do here. Half AB sine C. This would be A, this would be a B, and then the sine of this angle, which is 90. But that actually works out exactly the same as a half times base times height, because you'll just be timesing by sine C, which would be sine of 90, which would be 1. Hope I haven't confused anybody there. Either way, it doesn't matter. This is a nice one because you can do half base times height. Half times 7.58 times 9. If you're doing half AB sine C, you'd be timesing by sine of 90, which would be 1. So it's the same either way. So just type that in, times by 0.5 times by 9, subtract the 28.35, and we end up all together, I've typed it all in, with 5.76, so 2 decimal places. And that's that question done.